Welcome to your first lesson. Just as a quick reminder, take notes as you would during a normal lecture. However, write down questions you have and things that you may not understand very well, things you need more examples of. And when I go over each slide in class, please feel free to ask questions. Please feel free to ask me to elaborate or just simply go over things again as many times as you need. All right, so let's begin. This is a review of material from intermediate algebra and college algebra. So let's talk about the definition of a function. A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to, this is the keyword, exactly one member of the range. Here's an example. In this case, the domain contains the names of basketball players, and the range contains how many championships they've won. So Bill Russell has won 11 championships, Robert Ory's won 7, Michael Jordan's won 7, and Kobe Bryant's won 5. This relationship is a function because each member of the domain, the NBA players, corresponds to only one member of the range. For example, Bill Russell cannot have won 11 and 7 championships. Bill Russell can only win one number of championships, which in this case is 11. Another example, in this case, domain is the name of a city or a state, and the range is the corresponding baseball team. So Arizona, their baseball team is the Diamondbacks. Chicago has two baseball teams, Cubs and the White Sox. Baltimore has the Orioles. This relationship is not a function because one member of the domain, Chicago, corresponds to two members of the range, Cubs and White Sox. So since one member of the domain corresponds to two members of the range, this is not a function. When we're given graphs, we can use the vertical line tests in order to determine whether the graph represents a function. So recall, in order for a relation to be a function, each member of the domain can correspond to only one member of the range. So let's take a look at the middle graph first. If we take this domain, it corresponds to two elements of the range. In other words, this x value has two different y values. Therefore, it is not a function. Same thing over here. We can take this member of the domain, and it has two elements in the range. So therefore, this is also not a function. The first graph, however, is a function because you can take any member of the domain and it corresponds to exactly one element of the range. So we can use a vertical line test in which we draw vertical lines, and if the vertical line hits a graph exactly one time, it is a function. If it hits a graph more than one time, it is not a function. Now let's talk about evaluating functions. When we evaluate functions, the number or the expression inside the parentheses, this is the input. We take the input and we replace it with each x value on the right side. For example, if we want to evaluate f of negative 2, that means our input is negative 2. And this input replaces each of the x's on the right side. So we have 3 times negative 2 squared minus 2 times negative 2 plus 5. Remember the order of operations, exponents are done before multiplication, so we take the negative 2 to the second power first. This gives us 3 times 4. A negative times a negative is a positive, so plus 2 times 2 plus 5. If we keep going, this is 12 plus 4 plus 5, which is 21. And for proper notation, we would write f of negative 2 is equal to 21. Which means when the input is negative 2, the output is 21 for the function f of x equals to 3x squared minus 2x plus 5. Okay, this one I'll do a little bit faster. We have 3 times 0 squared minus 2 times 0 plus 5. 0 squared is 0, so this is 3 times 0. 2 times 0 is also 0 plus 5. This is 0, so our output is going to be 5. So for the function f, when the input is 0, the output is 5. And again, make sure to write this using proper notation. Now, instead of a number, our input is going to be an expression, which is x plus h. So once again, whether we have a number or an expression, each x on the right side will get replaced with whatever the input is. So instead of 3 times x squared, we will have 3 times x plus h to the second power. This x gets replaced with this input. Instead of 2 times x, we have minus 2 times x plus h, and we have plus 5. Okay, let's keep going. X plus h to the second power, this is x plus h times x plus h. Then we got minus 2 times x plus h, and we have plus 5. If I distribute, we will get x squared plus xh, which is 2xh, plus h to the second power, minus 2 times x plus h plus 5. Notice I'm doing one step at a time. In the order of operations, the exponent gets done first, so I'm doing that first. Then I'm going to distribute 3. So if I distribute the 3, I end up with 3x to the second power plus 6xh plus 3h to the second power. Now I distribute the negative 2, so it's minus 2x minus 2h plus 5. I look for like terms, but we don't have any like terms, so for proper notation, we would say that f of x plus h is equals to the expression on the right side. Okay, so take a look at these. If you have any questions, if you need more clarification on anything, remember to save those questions, write them down, and bring them to class. Okay, we're going to now talk about an important topic that's going to come up later on called the difference quotient. The difference quotient of a function f of x is defined by the following formula: f of x plus h minus f of x over h. So we have to first find out what is f of x plus h. We know what f of x is, that's given to us. So the main thing we have to figure out is what is f of x plus h. So our first function is f of x equals to 3 times 3x plus 5, and we want our input is going to be x plus h, which again means this x is going to get replaced with whatever the input is, which in this case is going to be x plus h. So we have 3 times x plus h plus 5. So f of x plus h is going to be 3x plus 3h plus 5. And I'm going to put this in parentheses because we're going to be replacing this whole expression with f of x plus h in a second. F of x is given to us as 3x plus 5, which again I will also put in parentheses. Now we're going to substitute f of x plus h with its equivalent expression, which is 3x plus 3h plus 5. In general, anytime you substitute, always use parentheses. So f of x plus h is equivalent to this expression. So we have 3x plus 3h plus 5 minus f of x. F of x is equivalent to this expression, which is 3x plus 5, and all of that is divided by h. So now let's simplify. The negative distributes to the second parentheses, so we have 3x plus 3h plus 5 minus 3x minus 5. So let's combine our like terms. We have 3x minus 3x, that adds to 0. We have 5 minus 5, that adds to 0. Don't forget the h on the denominator like I just did. So our final answer here is going to be 3h over h. And if I simplify this, it simplifies to 3. This can be a confusing concept. So once again, if you're not sure where any of these expressions or terms came from, then please ask me during class when I go over this. All right, next, let's do a function that's a little more complicated. F of x equals to 4x squared minus 5x. So our input in the beginning is x plus h. Where do we get that from? From the formula. The difference quotient is always going to be f of x plus h minus f of x over h. So let's first find what f of x plus h is. Each of the x's is going to get replaced with the input, which is now x plus h. So we have 4 times x plus h to the second power minus 5 times x plus h. Again, all I'm doing is I'm replacing each of the x's with this input. Okay, let's simplify. This is 4 times x plus h times x plus h minus 5 times x plus h. To save some time, I'm going to distribute, and you can work that out yourself. When we do distribute, here's what our answer comes out to be. It's going to be 4 times x squared plus 2xh plus h squared minus 5 times x plus h. Then I would distribute the 4, so this gives me 4x to the second power plus 8xh plus 4h to the second power minus 5x minus 5h. Okay, so this expression is equivalent to f of x plus h. F of x we know is just 4x squared minus 5x. That's the easy part. Now let's put all this together. First, we're going to replace f of x plus h with its equivalent expression. So in parentheses, I have 4x squared plus 8xh plus 4h to the second power minus 5x minus 5h. And we're going to subtract that by 4x squared minus 5x, all divided by h. Okay, let's distribute the negative over here. So we have 4x to the second power plus 8xh plus 4h squared minus 5x minus 5h. Distribute the negative. That's negative 4x squared plus 5x. All of that is divided by h. Now let's combine our like terms. We have a 4x squared and a negative 4x squared. We have a negative 5x and a positive 5x. So in general, any term that does not contain an h is going to get canceled out. It's going to add to 0. So let's look at what's left over. So we're going to have 8xh plus 4h squared minus 5h. So only the terms that contain the h are going to be left over at the end. That's a general rule to remember. And we're going to divide this all by h. So if you recall, when you divide a numerator by a monomial, which is one term, we can separate these into 3 different fractions, 8xh over h plus 4h squared over h minus 5h over h. And then if I simplify these, I get 8x. 8 squared divided by h is going to be h. The h and h are going to cancel out, and we're left with 5. So our difference quotient is this expression, 8x plus 4h minus 5. Again, it's a lot of work, a lot of things going on here. So think of questions you guys have.